What sets the Nordberg Barmac B-Series VSI apart from other types of crusher is that it uses rock to crush rock. The Barmac crusher uses a field-proven rock-lined rotor that acts as a high-velocity drystone pump, hurling a continuous rock stream into a rock-lined crushing chamber. Material fed into the top of the machine first builds up rock ledges and shelves to protect the metal frame of the crusher from rock contact, and then flows through the rotor and forms a protective bed in the crushing chamber. Grinding begins when the material enters the rotor, separates into 3 streams, and is flung outwards against the rock built up on the walls of the chamber. The material is accelerated by the rock-lined rotor and is continuously discharged into the crushing chamber at velocities up to 85 meters per second. This process replenishes the rock lining while at the same time maintains a rock-on-rock chain reaction of crushing and grinding. Size reduction can be achieved by impact or shatter attrition and abrasion. The crushing action reduces the feed to required specifications, with minimal wear and tear on replacement parts. The particle cloud in the crushing chamber, driven by the material expelled from the rotor, swirls around the chamber in a highly turbulent manner, and the particles collide, rub and grind against each other before losing sufficient energy to enable them to drop out of the particle cloud and leave the crushing chamber. Material can be added directly to the crushing chamber, colliding with the highly energized flow of material exiting the rotor. We refer to this flow of material as cascade, which acts as a transitory rock anvil absorbing the energy from particles being flung from the rotor. A high degree of control can be exercised over the crushing and milling by altering the ratio of feed entering the rotor compared to the amount of feed entering the crusher chamber via the cascade. By opening the cascade gate, we let more of the feed material into the rotor, drawing more power from the motor and producing a finer product. Likewise, by closing the gate, more material is allowed to flow into the crushing chamber via the cascade, drawing less power from the motor, and the product grading becomes coarser. Alternatively, the gate opening can be set to draw full power from the motor and the feed rate increased to deliver more material to the crushing chamber via cascade. As the chamber population increases, so does the crushing efficiency. This results in increased production with no increase in rotor wear nor power consumption. The changes to the cascade rotor ratio can be performed manually or be fully integrated into an automated plant system.